We're going to talk about specifying environment settings. So if you go to geoprocessing and you can click the environments. Okay, and geoprocessing operations are influenced by environment settings. These settings are like additional hidden parameters that affect how a tool is run. The environment settings dialog box, we go to geoprocessing, and environments allow you to view and set the environments for geoprocessing. There are a number of settings, but one of the most important is the current workspace. Most geoprocessing tools use datasets as inputs and then output new datasets. A workplace consists of a path to where these datasets are located. Complete path and file names can get quite long. For example, if you look at my workspace now, it's fine. So to avoid having to type these lengthy names every single time and possibly introduce typos, we can use the tool dialog to select layers from the current ArcMap document or to browse to the location datasets. For example, I'm going to change everything here because I'm not working on the geo database. And I'm going to put not in result. Exercise 2. See, I changed my path and this will be in result. And then click OK. So I don't have to connect my folder because in previous video I already saved this document in my exercise 2 folder. And we can also jack file from the ArcMap table of contents to the map. In addition, a workplace can be set to make specifying input and output datasets easier. After your workspace is set, we're going to specify only the base name. So in the example here, we will do I did was scratch workspace. It will be the result that my output and stuff will be there once I have a new layer. So on a tool dialog, then we can specify a feature class inside this workplace by typing only its base name. And when we click anywhere else on the tool dialog box, the parameter is automatically completed using the current workplace. As shown in here, I'm going to show you in a little bit. So now we're going to clip our clip tools again. If I drag, I can just select this layer. I'm gonna clip again, and feature I can just based on anything, soils, and then I can just click OK, clip again. So there are two types of workplaces. The current workplace, which specify by default where inputs taken from and where outputs are placed. And for the scratch workplace, which is primarily used by model tools to write intermediate data. There are also settings for specific data types such as a geodatabase, raster, or TIN, triangulated irregular network, and for specific types and functions such as random numbers. Typically, we need to set only a few of these environments for a particular workflow because many of them do not apply to the data and tools we are using. Environments are always at work. In other words, even if you don't specify them, they have a default values and are used in a tool. When a tool is run, for example, default output coordinate system is the same one as the input. So when you are running a tool, the coordinate system is not changed unless you specify otherwise on the environment settings. dialog box. So environment settings can be specified at a number of different levels. And there is a specific hierarchy to this process. So the first level is the application. You can right click in the Arc2 box window and click environments. This brings up the environment settings dialog box. Any settings created here are passed to the tools and they are called by the application. So I'm going to show real quick. So right here, that's the environment settings. The second level is the individual tool. Every tool dialog box has an environment button. So that's right here. When you click the button, environment, and I don't need it, and I can just close it out right here. When you click the button, the environment settings dialog box opens. Any settings created here are applied only to the current running of the tool, and these settings override the settings passed by the application. These settings are not saved to the tool but apply only to a single execution of the tool. The third level is a model. Environment settings can be created as a part of the model properties, which is separate from the settings you create on the tool dialog box. Any settings created in the model overrides the setting passed by the application or the tool dialog box settings. Model environment settings are saved as a part of the model properties. The fourth and the final level is a script. So environment settings can be also coded into a Python script, and this settings overrides the settings passed by the application or the tool dialog box. These settings are saved as a part of the Python code in the script file. So in general, environment settings are passed down in this hierarchical system, but you can override this system at each level. Okay, then we're going to use the patch processing. So most tools are a limited number, use a limited number of input datasets. For example, the clip tool uses only a single input feature class and clips it using a single clip feature class. What if you wanted to run the same tool using similar settings on many different input datasets? This is where batch processing comes in. In the context of geoprocessing in ArcGIS, batch processing means executing a single tool multiple times using different inputs without further intervention. All geoprocessing tools can be run in batch mode. Right-click a tool and click Batch brings up the batch window for the particular tool. The batch window shows a grid of rows and columns. The columns are the parameters of the tool, and each row represents one execution of the tool. Rows can be added, and the tool parameters can be specified for each run. For example, in the case of the clip tool, the batch window looks like the example here. So I have to get the batch here. Let's see. Input features and output features. If I have a batch, just give me 1 second. I need to put batch input data tool value batch project. Batch. Find my search window. Okay, right now if you see the batch, it's all with the geoprocessing. Let's see. Let's bring the clip back. Extension, spatial analysis is open. Alright, and where's my clip tool? Okay, there it is. Right now we cannot do a batch. Let's see. Input feature. If we cannot do it, let's see. Alright, we're gonna continue and see. We will come back for what happened to the batch later. Using batch. So the batch grid contains 5 rows, indicating the clip tool will run 5 times based on different inputs. So the cells in each row represents the tool parameters. The button on the right row for adding and deleting rows, changing the order of the rows, and examining the cells in the batch grid for valid values. Entering parameters for the batch grid is similar to working with a regular tool dialog box as follows. So we're going to click inside a cell and a drop-down arrow appears. This allows you to select from the layers in the table of contents of the current ArcMap document. So we can drag layers from the table of contents into the dialog box. And we can right click in a cell and then click open. This will bring up a separate dialog box that has the familiar drop down arrow and a browse option. So right click in a cell, click browse, and this is a shortcut to the browse option. So in addition to completing the batch grid cell by cell, there are a number of ways to quickly enter the parameter values for multiple cells, including one copying and pasting cell values and using the fill option to fill cells below a clicked cell with that cell's value. One important feature of the batch window is the check value button. When you enter values into the batch grid, there is no automatic arrow checking. This is in contrast to regular tool dialog boxes, which automatically validate parameters. For example, checking whether a particular input dataset exists when the check values button is clicked. All rows are scanned for errors and output dataset. Names are created if needed. If errors are found, the color of the cells changes. So some common errors include the following: green cells mean that a required parameter has not been specified. Red cells indicate an error was found and the tool will not run. So the common reason is that the input dataset does not exist. Yellow cells indicates a warning. The most common reason is that the output may not be what you expected. Several other cell colors are possible. White cells means the parameters are correct. Gray cells means the parameter is unavailable because it has no use, given the value of the other parameters. Finally, blue cells indicates a row is selected. Alright, so running a tool, we're going to bring the batch project out. Batch project. Okay, now we can have everything here.